In this video, I'll explain about harmonic functions. So let us see definition of harmonic function. A function u of x comma y which satisfies Laplace equation uxx plus uyy equal to 0 is called harmonic function. So we need a multivariable function to define a harmonic function. Here I have considered two variable function. Variables are x and y. If a two variable function satisfies this Laplace equation, partial derivative of u with respect to x twice. Here, second order partial derivative of u with respect to y. If you add them both, then we have to get equal to 0. That is, harmonic functions are the solutions of this Laplace equation. For example, take this function u of x comma y equal to x cube minus 3xy square plus 3x square minus 3y square plus 1. We have to check is this function harmonic. So for that I need the first derivative, partial derivative with respect to x, then second order partial derivative with respect to x. So ux is, while differentiating with respect to x, y is taken constant, 3x square minus 3y square is a constant. Partial derivative of x with respect to x is 1 plus 3 2 is a 6x minus 3 is a constant. Y square is also constant. 0. Derivative of 1 is 0. So now once again differentiate this with respect to x. So 3 is a constant. Partial derivative of x square with respect to x is 2x. So 6x minus 3 is constant, y is also constant, it is 0 plus 6x derivative with respect to x is 6. So this gives you 6x plus 6. Now I have to find out uy and uyy. So which is equal to uy, partially differentiating u with respect to y. So derivative of x cube is 0 minus 3x is a constant, y square derivative 2y plus 3x square derivative 0 minus 3 is a constant, derivative of y square with respect to y is 2y plus derivative of 1 is 0. So this gives you equal to minus 6xy minus 6y. So once again find the derivative of this with respect to y. So minus 6x is constant, derivative of y with respect to y is 1, minus 6 into derivative of y with respect to y is 1. So that gives you minus 6x minus 6. Therefore, you check now uxx plus uyy, add these two derivatives, partial derivatives. So I'll get 6x plus 6 minus 6x minus 6. So all get cancelled, value is equal to 0. Therefore, this function satisfies the Laplace equation. Hence, the given function is u is harmonic function. Now, properties of harmonic functions. If f of z equal to u of x comma y plus I into v of x comma y is analytic on a domain D, then both u and v are harmonic on D. So if you have analytic function which is in this form where u is the real part of the function and v is the imaginary part of the given function, then both these u and v are harmonic because the condition given is analytic. If the function is analytic, then its real and imaginary part functions are harmonic and they are called as harmonic conjugates. U and V are harmonic conjugates. An arbitrary pair of harmonic functions u and v need not be harmonic conjugates unless u plus iv is an analytic function. Therefore, to say they are harmonic conjugates, u plus iv must be an analytic function. Otherwise, any arbitrary pair of functions u and v need not be harmonic conjugates. One more property, if u is harmonic on a connected domain D, then for some v means there exists another function v such that u plus iv is analytic in a domain T. So for a harmonic given harmonic function, you can find its harmonic conjugate so that by writing u as its real part and v as its imaginary part, we will get the analytic function associated with the given harmonic function. Solve few problems to understand properties of harmonic functions. So here given, check whether this function harmonic. If this function is harmonic, then you have to find its harmonic conjugate. So first let us check whether the given function satisfies Laplace equation. So you find out ux, partial derivative of u with respect to x, that is 2x, this is 0. Uxx, partial derivative of 2x with respect to x, that is 2. Similarly, find out uy minus 2y, partial derivative of u with respect to y, minus 2y. Now second partial derivative of u with respect to y gives you minus 2. Now uxx plus uyy equal to 2 plus minus 2, which is equal to 0. Therefore u satisfies Laplace equation, hence u is harmonic. Function u is harmonic. Now, if it is harmonic, then you have to find its conjugate. That is, you have to find out V. Now, using third property, if U is harmonic, then there exists another function V such that U plus IV is analytic function. Analytic function means it satisfies Cauchy-Riemann equations. So, Cauchy-Riemann equations are given by, here we have ux equal to vy and uy equal to minus vx. So I don't know the function v. I have to find out that function v of x comma y, which is that function that I have to find out. But we have this condition, that is Cauchy-Riemann equations, ux is equal to vy and uy equal to minus vx. This condition will get because the function u is harmonic, there exists its conjugate such that u plus iv is analytic. Whenever you have an analytic function, then any analytic function satisfies Cauchy-Riemann equations. Therefore, first find out ux, which we already have here. Ux is equal to 2x, which is equal to vy. Uy equal to minus 2y, which is equal to minus vx. Therefore, make use of any one of the equation. I will use this. Vx is equal to 2y. Now you have to integrate this. Integrate with respect to x. So v is equal to, or else vx with respect to x is equal to integral of 2y with respect to x. So that gives you integral and this derivative differential cancels. So we'll get v equal to 2y is a constant, integral of 1 with respect to x is x, plus you have to add some function of y. That is because we are integrating with respect to x. Y is a constant, therefore it is some function of y. So we got v as 2yx plus some function of y. To evaluate v, let us make use of this expression vy equal to 2x. Now here we have vy equal to 2x from this. Therefore, I got v. I will differentiate v with respect to y partially. So I will get 2x into derivative of y with respect to y is 1 plus f dash of y. So which is equal to vy is 2x. 2x cancels, f dash of y equal to 0. That means derivative equal to 0 means f of y must be equal to some constant. So f of y equal to some constant c. Therefore, I got v is equal to 2xy. Let me substitute here. F of y equal to some constant c. So, this is the harmonic conjugate of the given function u. Now one more function. Here you have to find out that analytic function f of z equal to u plus iv, where u equal to, this is given. You have to find the analytic function means you have to check is this function harmonic. Then you have to find its harmonic conjugate. Then add the functions u and v with the u as real part and v as the imaginary part. So first let us check is u harmonic. So for that it has to satisfy Laplace equation. So ux is 3x square minus 3y square into derivative of x with respect to x is 1. Uxx is equal to 6x. This is anyway 0. Uy equal to 0 minus 3x into derivative of y square with respect to y is 2y. So uyy equal to here minus 6x is constant, then derivative y is 1. Therefore, uxx plus uyy equal to 6x minus 6x, which is 0. It satisfies Laplace equation. Therefore, u is harmonic. If u is harmonic, there exists v of x comma y such that u plus iv is analytic. We have to find that analytic function. So if this function is analytic, then it satisfies Cauchy-Riemann equations. They are ux is equal to vy and uy equal to minus vx. So therefore ux is 3x square minus 3y square, which is equal to vy, and uy is equal to minus 6xy, which is equal to minus vx. Let us make use of this equation now. So vx is equal to 6xy. You have to integrate with respect to x. So we'll get v equal to 6y into x square by 2, plus integrating with respect to x means adding constant as a function of y. So this gives you 3x square y plus fy. This is the function v. But we have here, make use of this another equation. So this is equal to, now differentiate, we have here vy, therefore differentiate this expression partially with respect to y, which is equal to 3x square plus f dash of y. That is equal to vy value is 3x square minus 3y square. Hence f dash of y equal to, we will get, so 3x square cancels, minus 3y square. So we want f of y. So integrate this with respect to y. We'll get f of y equal to 3 minus 3y cube by 3, which is equal to minus y cube. Therefore, we will substitute this in the function v equal to 3x square y minus y cube. This is the harmonic conjugate of the given function u. Now the analytic function is analytic function, which is equal to u plus iv, that is equal to u is x cube minus 3xy square plus I into v is 3x square y minus y cube. This on simplification, I will get it as x plus iy whole cube, which is nothing but z cube. This is how we find the analytic function. I hope you understood the concept. Thank you for watching.